Hello everyone, in this video I will use this demo model to show you how you can, in a couple of minutes, let's say 20-25 minutes, go from this full CAD model to a model which contains not only the 2D, 3D mesh, so Hexa and or Tetra, but also with the automatic assignment of materials and properties. So let me show you in the next minutes how to proceed to get to such target. And for this we need a couple of prerequisites to count them 3 prerequisites. First prerequisite is about the parts themselves, and if I look at a given part and scroll down to the attributes, you can see that in this model I defined some of the PDM data, starting with PDM MID, which will be the material ID, PDM material, which is the material name we're targeting to assign. The PDM thickness, I left it to blank, which means HyperMesh will be in charge of computing it based on geometry properties when extracting the mid-surface, if I do the 2D mesh. And the PDM mesh flag, which is nothing more than a tag. And this tag you can assign any string value as you want, so you can sort by saying 2D mesh or 2D mesh 2mm or 3D mesh or Hexa mesh, whatever. It's up to you, it's a free field. It's just a way for you to sort parts depending on the mesh strategy you want to apply. One question is how to get this PDM data populated. So first option is to collect them from the PLM system. But if you don't have access to a PLM system, it can be even possible to load them from geometry. So if you go to File, Import Geometry, and let me take a step file for instance, if you look at the geometry import options, you have a PDM attribute section here where you can map some data that can be stored into the CAD with the PDM data section. If you don't have access to PLM and you don't have any information in the CAD, then you can still have 2 options. Either do it by hand or use some AI learning mechanisms in HyperMesh, especially for fitting the PDM mesh flag based on part recognition. This method I will show them. I will record another video, separate video for this, and I will show how to proceed. Prerequisite number 2 is about material library. So let me create here a dummy material so that I can go to the material browser. When you are in HyperMesh, anytime you create a material, you can save it in a local database only by doing right-click, library, save. And once you've done it, you can load it either by its ID or by its name. So I would really recommend you, and only if you work with a part browser, but in all the cases, to save all your frequent materials in your local database. If you want to go further, this database, it can be shared across multiple users through a PostgreSQL database, but it is one way to do it. And we have another way to call materials, which is from AMDC, Altair Material Data Center. I will show it later in the video. So prerequisite number 2, material database. And to start this process with the part browser, you can either get all your materials of interest for this model loaded or leave your session empty. Both will work properly. You see in this model from the start, there is no part, there is no property series, there is no material. Prerequisite number 3 is about the representation and the representation controls. Representation controls mean defining your automated method for a given target mesh. So here you see that I have different mesh, target mesh for shell meshing, crash 2mm, crash 5mm, durability, and VH. Each of them rely on a given param and criteria files. So the first one, they come from the installation, and you can retrieve the param and criteria file in the installation. And then you can create any extra representation by yourself and specify the parameters of interest. So here, for instance, I have a representation for the Tetra Mesh, 2.5mm, minimum element size 0.25, and a growth rate to 1. I have one requirement for Hexa Thin solid with a 2mm mesh. I have a Midmesh with 3mm. So here you're defining basically what are your strategy methods, and you can have as many methods for one given type as you have target mesh. So here you see, for instance, that I have one Midmesh for 3mm and one Midmesh for 5mm. Once these three prerequisites are completed, then you can start to work with the part browser. So let me pick again this part, go to the PDM mesh flag and say that I want to add a column. Now I will see this PDM mesh flag here, and I can filter, and let's start with, for instance, Hexa. I will select this part, Control A, and I will say right click, representation, create, and I will send it Hexa Thin solid to this representation. Please note that we have 47 parts selected on screen. Let me hit on OK. And what happens is that HyperMesh is creating one separated HM file per unique part. So what do I mean by unique part? If you zoom in the model, you see that several parts look the same, and they have been instanced together. You see the infinite symbol at the bottom of the part, which means once the parts are all exported, HyperMesh is running only one instance of each unique part. So instead of the 47 parts, we are just meshing 4 parts with the Thin solid method. And when the model will be reloaded, when the Thin solid mesh will be loaded in HyperMesh, we'll sync all the instances so that they all have their mesh. So here you see the mesh for the 4 parts has been done. Do I want to load for the 47 parts? Yes. So it can take a couple of seconds. Let me hide the geometry just for one moment. You see that all the parts which required thin solid have been realized, have been meshed. Now that we've done this, let's go back to the part browser and let's continue our journey. And after the Hexa mesh, let's do the Tetra Mesh. So 3D Tetra Mesh, for instance. Enter, Control A, representations, create, and I will ask for the Tetra 5mm. Let me open here the timer. Let me put it in short mode. Okay, let me click on OK. Run the timer, because I will probably pause the video, not so that you don't have to see just my batch mesher working. This is not the intent of this video. So again, all the unique parts are being exported to from HyperMesh to be sent to batch mesher. And so once it will be done, they will be used or they will be loaded again in HyperMesh. So 11 parts were saved. The batch mesher will start. Here it is. And from there, let me pause the video and take back the control in a couple of seconds. Now all the parts have been completed in the batch mesher. We're getting to the post-run procedure. So we are still waiting for a couple of seconds before the batch mesher is completed. And once it is done, we will be able to load all the Tetra Mesh into So do I want to load the representation for 27 parts? Yes. And now you see that the Tetra Mesh has been loaded. So now we can continue still our journey. So instead of 3D Tetra Mesh, let's go. So let me pause this one, reset it. Let me go by 2D Mesh, enter. Again, Control A, right click, representations, create, and I go to crash to millimeter. I can change the mid-surface method extraction if I want. Let me go with offset. And I can click on OK. Here again, HyperMesh will need a couple of seconds to up to 1 minute. In order, sorry, I start to run the timer here, in order to export each unique part individually. And once it is done, the batch measure will start. Let me just try to see if the export is done soon. Otherwise, I will put the video here and wait for the batch measure to be almost complete to start again the video. Okay, let me pause now and see you in a couple of minutes for the delivery of the 2D mesh. So just reactivating for a moment my microphone and the video, just to mention that when you're dealing with shell mesh, you have not one representation sent to the batch measure, but two representations. Command stands for mid-surface extraction, and crush to millimeter is for getting the mesh once the mid-surface has been extracted. So this is a reason why you see twice more representations with a shell mesh than with a thin solid or with a Tetra Mesh. So batch measure is still proceeding. You see that almost all the mid-surface extraction has been done. So we're waiting for the mesh to be completed. Let me pause again and see you again in a couple of seconds. So just to catch, there were some error to mesh some of the parts. So we'll see later on how to detect them in HyperMesh. But yeah, you can capture these ones and see why, or at least identify which one failed. So we're close to get the final delivery. There are still 4 mesh to be done before completing the mesh. So let's keep the video running. You see 2 parts have just been completed. So it should be a matter of seconds before batch measure close, and then we'll need something like a couple of seconds again for the pop-up to load in HyperMesh and ask for loading the different parts. So what is HyperMesh doing behind the scene is registering for each of the, or saving for each individual and unique part the representation of the mesh representation that has been created. And once all the representation have been saved behind the scene, we will be able, or HyperMesh will populate, or will shows up the pop-up to ask if you want to load the mesh representations inside HyperMesh. Okay, just paused a little bit the video just to save some time, not to have some blank during the video. So now the 2D shell mesh is ready to be loaded. Let me hit on yes. And let's have a look at this part here with this part with 3 holes here. You will see that when loading the 2D mesh, this part will vanish because this was one of the parts with a mistake. So how to get them? The way that we have to detect them with 23.1 is to look at the part whose representation is crash to millimeter, or any of the representation you selected, but which has no thickness assigned, which means it is empty, they have not been processed. If we look at other parts, you can see that in our parameter criteria file, the settings were done in such a way that there is a washer around every hole we have something which is quite regular. So this is quite a nice mesh. So here you see within, let's say, 15 to 20 minutes, I was able to get a first mesh done for all my Tetra mesh, all my Hexa mesh, all my 2D mesh. Oh, there's one part I haven't proceeded yet, which is the Midmesh. So let me do this one, representation, create. Let me take the Midmesh representation, it should be pretty fast, okay. And I will send it to the batch mesher. And here you say that work is in progress. So it should take a couple of seconds to be done. And then I will be able to load again the results directly in the session. And with it, every part I need either to need in with 3D Mesh or with 2D Mesh will be loaded into HyperMesh. So the meshing has been done, the post-run procedure is going on now, and then we'll be able to load the results. And do I want to say the last message? Do I want to load the new representation? Yes. So now all the mesh have been done. Let's have a look now at my model. Let me go to properties. So first, let me take all my properties, Control A, select and change autocolor for this, for all. You can see for the final one that I meshed here, I could tune a little bit my parameters because the Midmesh is not really terrible here. I have multiple properties assigned to this Midmesh, and the reason is because I have different thickness in it. There's just one small glitch in 23.1, which will be fixed in 2024. For all other properties, the material was assigned to the property, but for the properties coming from the Midmesh, you need to assign by hand the material. So if I go to Midmesh, if I go to this part, for instance, right-click, edit one part, material should be ABS. So let's go to property, select my three last properties, select material, ABS, okay. And now we have a final step. Let's go to model, material. So as I mentioned, the material have been populated. If you leave them blank before loading the session, the entities or the information that you will see in the model are dummy information. It's not loaded with the proper attributes, so which means you need to load them. One way to load them is to go from right-click, library, load, wrong click, right-click, library, load from AMDC. So AMDC, Altair Material Data Center, you need a proper license to get access to it, so feel free to review with your sales contact if you have access to Altair Material Data Center. Here I can pick a material, select the type, so MAT1, and make sure that I share the same ID, 1004, and then I can save to my material. So here you can see that the values are not the same anymore that for the other ones. Or I can select all my materials except this one, right click. If I save my library locally, I can say load either by ID or by name. And here I have all my existing materials in my library. I can hit on OK. And now all my material are with the proper values. So as a conclusion, you can really use Part Browser to streamline your first mesh, your preliminary mesh. Once it is done, you can review by material type or whatever to check the quality of your mesh and possibly fix any part. So here the Midmesh, for instance, I could work again on it, There are probably some other parts I need to figure out why the mid surface failed for this part, but there are many parts which are meshed where I don't need to review anymore. So please feel free to test the part browser and to share any feedback so that we can continue to improve it. Thanks for reviewing this video.